Question is, do I need region out? I don't think so. Let's remove region. Why? Hello, wise mind. Didn't see you there. Okay, so we get a new point in between, maybe. Yeah, I have 2 points, 0 and 1. And then we get a new point here, which then gives rise to 2 new cubics. Cubic that goes through 0 and 2, and a cubic that goes through 2 and 1. And not just goes through, but also has the same derivative there. The moment that point 2 comes in, then we are at find extreme, or what was it called? That would be this one. So point 2 is inserted in the chain, so now we have 3 points on a row. And it turns out to be in the middle of 0 and 1. The right node is the next node, meaning larger W value, so to the right, that means point 1. So point 1 is not at the end, because it exists. And then that cubic is initialized, fitted through point 2 and 1. We do stuff. And I also check that the new node is not the beginning, it's not the first one, so a previous one exists, which is 0. And also initialize the cubic between 0 and 2. Which also draws cubic. So then we are where we were, if you can see that. But now what do I want to do? What I want to do is I want to know that I want to jump to this point. Well, it already seems to know because there's a green arrow here. But why do we want to jump to this point? And the reason is we have 2 cubics, this one and this one. And we are looking for a minimum. And this cubic has a minimum that lies between 0 and 1. And this cubic has a minimum that does not lie between 0 and 1. And it had to lie between 0 and 1. Because the red arrows. So we go one step further, then I still know that the red arrows are at 0 and 1. And we must find a minimum in between these 2 points. That's going to be this minimum. I want to have the first minimum, the minimum closest to 0, I think, sort of. Not sure actually, but So because this minimum is not between 0 and 1, it just is not interesting to jump to that. It's definitely not the minimum that we were looking for. And this one is, as you can see, it's just almost the same at the right spot. So I think the correct algorithm here is find the minimum of both cubics, find which one lays between 0 and 1, and if there is only one of them, then jump to that. Well, that's the case here, so that's what we do. And then I can also move the red arrow from 1 to 2, because now I know that it has the minimum is in between 0 and 2. It kind of follows from the fact that I'm using the minimum of this cubic that goes through 0 and 2. However, that's not what I'm doing. What I'm doing is looking if there is a minimum between 0 and 2. And looking if there is a minimum between 2 and 1 for the other cubic. So this one does not have a minimum, and this one does have a minimum between 0 and 2. And therefore I jump here. But yeah, imagine that point 2 was here, then there was no minimum between 0 and 2. Imagine that the cubic between 2 and 1 would still have the cubic outside, so that was definitely not useful. And I still would want to jump to the minimum of the cubic through 0 and 2, which then had a minimum here, which is not in between 0 and 2, but is between 0 and 1. So that's what I really want. And I think that the comparing, like, are we left or right 1, or are we in between this, or left or right of 2, or whatever, all that comparison, I'm going to do that in the algorithm function. And I'm just going to write a simplified version of find extreme, which simply returns the minimum of the cubic. And no longer checks if it is in the right place. I think what I can do best is analyze the cubic. So I'm going to make a class which is called analyzed cubic, which is maybe inherited from cubic, initialized with the cubic, and then calculates the inflection point, which is in the middle here, or here for the other one, as well as the distance from the inflection point to the local extremes, if they exist. So in this case, that would be half the distance from here to there, or from here to there. I want to work with A, B, and C, but it's just for me. In reality, you just want to have a cubic, of course. And let's just, I don't know, derive it from cubic. Yeah, which is an array. What the fuck? Public. Let me make this thing protected so I can just access it directly. All the stuff then that I need is protected. Is make that private. can store that there at the moment. So that would be a member function of the base class. So math cubic polynomial is this function. Square root of d is that is the square root of this thing. I guess if I try to take the square root of a negative number, I just get is not a number. Or do I need this check? Hello, Abhishek. Okay. Good to have a watcher, a viewer. Trying to find out if it is safe to call standard square root on a negative number, or that it might throw sometimes. Maybe it's just reporting something in error number, but looks like theoretically it can throw exceptions. Let's just not try to call it in. Kinda annoying, however. But okay. But okay. Let's have to calculate it, maybe. Okay, so yeah, let's do it like this. I'm going to set it to standard, not a number that exists, right? Thought that exists. So we'd have to check this, and then it will only work if we have acquired not a number. I think I'm already making use of that. Actually. That's usually true. Yeah. Could still check it, I guess, but Is that the error or was it just numbering? I think it was numbered limits, but we'll see in the compile error, or I can just click on it, I guess. It's limits, yeah. I had the feeling. This one's much shorter. Okay, this static assert, then probably you should go in the header. Because this is where I'm going to initialize this to also number of limits. Okay, so that would be this one. And then we need to set that one. Also need to be calculated, so I'm not sure I can do that in the initializer list. Can we do that in the initializer list? Why is it an int anyway? Probably need to. No, I need to compare with it, I guess. Yeah, it could even be a boolean. Let's initialize it to 0. And then if the derivative is positive, I set it to 1, and if it's negative, I set it to -1. Okay, now I need to calculate the derivative in the inflection point. I could just calculate it by passing the inflection point to the derivative, but it feels like I'm then probably doing too much calculation. So what do we really have? We have a plus b plus c plus d plus terms x squared x to the power of 3. The derivative is then b plus 2cx plus 3dx squared. And the inflection point is, as if I would know that, is this, whatever that is. Let's see, index 0 is A, that is A, B, C is minus C, divided by 3 times D. Oops, I meant to put that there. So the derivative is filling this into that. B plus 2c times this. Well, the really questions, can we simplify that? Yeah, could get a c out of this. C squared. This is c squared 9 d squared. So this 3 drops away against this, and the d drops away against 1d, and then we have minus 2c squared divided by 3d, and here plus c squared divided by 3d. So that means 2 drops out, and then all of that drops out. I can't make that any simpler. Yeah, but if I did not make a mistake yet, of course. Yeah, always scary. This happens to be minus c squared divided by 3d plus that. Which is minus this minus that. Which is divided by 3d here. Then this one drops out. And you have to multiply with 3d here. And now that this is equal to d. So this is actually equal to minus d. Oops. Minus d divided by 3d. And since d is positive, so I'm not really interested in that value if d is not positive. Let's put it that way. I could just look at the sine of 3d, which means I just look at the sine of d. And d is just coefficient 3. Yeah, obvious. So let's undo everything again. Now we finally understand what's going on. I don't think I made a mistake, but let's check it. Let's double check it. So there was a link somewhere, which was, I think, in this. Yeah, this link. It's finding the cubic. Actually, I want to know the. No, anyway, probably this link. So this would be D under the root. Which is C squared minus 3BD. And again, 0 is A, 1 is B, 2 is C. So this is C squared minus 3BD. And then only if it is larger than 0, we can take the square root of that, obviously. And then the trick here was that if we don't have extremes, it's monotonically rising or monotonically going down. And for x going to infinity or w going to infinity, it's the coefficient 3 that determines where we go to, because it's an odd power. So if d is negative, then we go to minus infinity, and if d of coefficient 3 is positive, we go to plus infinity. Which obviously means that very far to the right, that determines the slope. Thus, if this is positive, then the slope is positive far to the right. And since it's monotonically rising, the whole thing is positive. Therefore, the sign in the inflection point is positive. Likewise, if it is negative, then we are monotonically going down. But that is if we have no extremes. If we do have extremes, then it's the cubic looks like this. It goes up, and then we have a local extreme, and then it goes down, and then we have the inflection point, and then it goes up again. So in the inflection point, the derivative is opposite of the derivative at plus infinity, which you determined here. Therefore, negate it, and we're done. Yeah, definitely correct. Let's add this to the CMake file. No, just see if it compiles. It did not compile. No, it does. So we go back to algorithm. So I'm not even going to call find extreme anymore. Delete this whole shit. Find has right has extreme. That is going to be disappeared because I'm not initializing it anymore. Same here. What I am going to do is create the new analyzed. Should it not be with an S? Never know. Probably one is American and the other one is English. I always use American. I mean, you gotta pick one. Analyze predominant views in the American. Okay. Analyze it is cubic. Now we have a right one and we have a left one, and it's super annoying that yeah, really, no. Sometimes you don't have them. The special cases are killing me. Maybe I can draw my conclusions right here and then put the conclusions in this scope instead of creating these things and then drawing conclusions later on. I mean, right, like here, I just need to know if the thing has an extreme and stuff like that. So I don't know yet. We'll just try something out. So let's try it inside here. Very temporary stuff. So and I'm copying this from the cubic, which it was just initialized, and I bet I can access it like that. And then we can do the same. Oops, the same thing here. But no, I'm not happy with it. Yeah, maybe not do it in the constructor then. It's just the way it is. Wait a minute. Yeah. But then. I'm not sure what I want to do with it yet. Oh yeah, of course. I was going to look for which one has the extreme that we want in between those 2 points. So yeah, one, does it have an extreme? If it has one extreme, it has 2 extremes. So either it has 0 extremes or 2 extremes, more or less. And then we want to find out. I just want to get the extreme of that I'm interested in. Of a given cubic, if the cubic exists. So yeah, I might not continue here for now. Look exists, analyze it, and now I want to know where is my extreme. Is there an extreme? Okay, so if analyze cubic has extremes. Now we know that we have extremes. And then I want to get my extreme a cubic dot get extreme. Which one? Well, the one that I'm interested in, which is next extreme type. An extreme is, sounds like a point, but I'm only talking about one coordinate. So let's call this thing extreme W. I think I'm going to stop adding a local. I mean, every time I talk about an extreme, it's just always a local extreme. Why would I keep typing that? Okay, I'll leave that. It's in the comment between parentheses. Now, let's add has extremes. Maybe I should leave it at not a number instead of setting it to 0. I mean, if the square root is exactly 0, then we have a curve like this. It goes up, and then it goes horizontal during one point, and then it goes up again. I mean, there's virtually no difference with just going up continuously. There is no local extreme. Only if this is infinitesimally above 0, we have something that you can zoom in and zoom in and zoom in, and then you will see this. Even the maximum and the minimum could be super close together, but they are there. And who's to say what is close? So yeah, I just don't want to do this test. It's a ridiculous micro optimization. But no, what am I doing? And still, I'm doing it. Right? Which then I have to make true, of course. Now d must be larger than 0 before we take the square root. And even then, it might still be... No, that's not true. I thought maybe d is so small that it's positive, but if you take the square root, it becomes 0. I don't think so. No. Not even sure that's possible. The IEEE definition of the floating points. Right, then I have to implement this one. Well, obviously this is extreme type, and every time you add a new header, you have to add it at the top. I refuse to explain why. Well, that's not true, of course. The newest headers must be on the top. So if later you add a standard header, then you have to add it at the bottom. Get extreme. Okay. So we need to calculate a sine. And then return the inflection point. Plus the sine times, and we're going to multiply with an integer. Or shall we just do a branch? Let's do a branch. Seriously, am I going to do a branch? How fast is multiplying with 1? Would it be faster than multiplying it with something else? Okay, so when is it left off and when is it right off? Well, that depends on two things. What extreme am I looking for? And, what is the derivative in the inflection point? So subtracting would be okay if we say we have a curve like this. If we're looking for a maximum and the sign is negative. I'm going to minimum. If it is minimum and the slope, if you're looking for a minimum and the slope is positive, then we want to subtract. Really. But on the other hand, this means that I could just multiply them and then demand that it is -1. But in one case it's -1, in the other case it's +1. So really I could just do two multiplications and an addition instead of a branch. What do you think? I think I'm gonna leave it to the compiler. Compiler will probably figure this out, right? You mean it knows that this is equal to -1? Doesn't know that this is equal to 0 or 1, but it doesn't know that this is true or false. It doesn't know that the other value is -1. So it can't do the trick that I just said. I have no clue whatsoever how quick integer multiplications are. And it doesn't matter what the value is of that, of an integer. So let's find this. I mean, how fast are integer multiplications these days? Yeah. So somewhere between a quarter and 5 cycles. Well, now I know what is fastest. But hey, maybe the hardware does optimize multiplying with plus or minus 1. In that case, I have a good feeling about doing that instead of a branch. Let's attempt to be smart, even though, you know. Yeah, so this is minus, then it's left of the inflection point. And minus would happen then if this is minimum and this is positive. Yep, and that's correct. So now I have the extreme value of this cubic. And we need to know if it is in between the 2 points that I have. Which points? Wait a minute. I don't know the next point yet. That would be this one. Okay, let's it's not a critical point anymore. It's going to use right extreme W. I just set that value here. Yeah, but also I need to set that boolean, the boolean back as extreme. Holy shit, this is good music. Now please give me a tone shift. Oh, it just continues. It's exactly the same melody all the time. It started so good. Yeah, okay, now it gets boring. Yeah. Sorry. I think I already have my left note set. What is it? No, the right wolf here. Left wolf and right wolf. I could use these. Yeah, let's go back. does this have to be less than or equal? Or just less than? I'm gonna go for less than. Left off could be null pointer. What does left off means? Left off means to the left of that thing. Must be to the left of the thing. So that's totally not correct. That must be left of that thing. Is it now left of the thing? Now it's left of that thing. Yeah, this is better. If there is no left off, then anything goes. So it is kind of not left off. Or the value is left off, left off. And then the same thing for the right side. So not right off. Or right off. Yep. So the right extreme is on the right of right off. That must be on the right of right off. Using that then makes that work magically. Right, we can do the same here. Oh, substitute. Okay, wait a minute. Let's also fulfill that. Okay, I think that now nothing should have been changed, so basically we get the same effect as before. Also adding the header. Well, we don't. The green arrow now moved here. Yeah, totally not changed. Apparently it wants to go to the inflection point of this one instead of to the minimum of that one. Ouch. the hell did that happen? Debugger. I'm not going to read the debug output. I doubt if it gives enough information to begin with. Yeah. Where do I want to look? I have no idea. Let's first find that point. Yeah, just here. Okay, sure. Just here about line 137 in algorithm.cxx. So we get a new point, current, at minus 38.8. So that's our new point here is 0.2. Added to the chain. The right node is obviously 0.1, yeah? I mean, this is inserted, and therefore left node is 0 and the right node is 1. You can see that here. We're looking at the label. There should be a label here. Label is 1, yeah. So the right node is number 1. And of course that was also correct. That is minus 22. Next. Right node is not at the end. Initialize the cubic. Well, that worked. Analyze the cubic. Could step into that. Maybe that is a failure. But let's not do that. Just has extremes. Well, the thing totally has extremes. It's even being drawn here now. So we have this thing that has extremes there. One there, one there, right? But how do we know that? Well, I can actually just print a cubic here, and then we see the cubic, and the inflection point is minus 25. Yeah, okay, so here's the inflection point of the thing. And the square root of d is 1. Oh, well, no. This is correct, but this is nonsensical. This distance from the inflection point to the minimum or maximum is clearly somewhere around 15, not 1. I'll just stop here, fix that first. But let's continue anyway. Next, wait a minute. Has extremes must return true, because the square root of d is a number. Well, that's correct. So reflection point is here, and it says +1, so it wants to go to the right in order to find the minimum. Just the distance that it goes is way not enough. And this was also correct. -25, yeah. So then after this step we have an extreme of -24. Step. Next. And then this checks if it falls in between 0 and 1, and it does, because we made such a small step. This is a much more sane value, I have to say. Reflection point to there. So let's say distance between here and there, double that value. 12-ish. No. Now it's too large. Square root of d is nonsensical again, eh? Reflection point looks correct. Sign of derivative also correct. What kind of values are these? They look a little big. They look big to me, but okay, probably correct. I mean, it's drawing it correct too. So do we have extremes? Yes. This has extreme. Is get extreme. What? What a nonsense. That is completely wrong. This is a Boolean. That should have been that one. Okay, now here I quit. Is routine Alice still there? Because I wasn't paying attention to the chat as usual. With only one viewer. It's Alice or nobody. Yeah, let's just do it again, and I think that was... Oh, 137. No, it wasn't, because otherwise it would not have stopped here. It was 137, but I changed the code. It is 137. I don't get it. Yeah. Nobody gets this. Really. How the hell is this possible? Does it make sense? Does it make sense? It doesn't make sense. Maybe it does make sense though. It should be c squared. Wait a minute. ABC. C squared minus 3 times BD. AB. T. Hmm. Stumped. Oh, I will get to divide by something. Yeah. I have to divide by 3D or something. Okay. Damn it. Where's my link? The link. Yeah, I'm stupid. I'm adding and subtracting the root, but I have to divide by 3D. Yeah, maybe I should incorporate that in this thing. What am I doing? it works again. Although before I saw the green arrow here, I think that stopped working. Oh, I'm sure I did. It doesn't really work therefore. Nope, does not work. Looks like they jumped to the maximum of this curve. Or maybe the maximum of that curve. Wow, you're looking for a minimum. Oh, yeah, never mind. Arg. My whole derivation of which way to go changed, because now we divide by 3D. I think this line is now broken. No, the line is correct. The calculation of this is broken. It looks like it makes sense, so. I changed. Okay, I changed the sign of this thing with the sign of the coefficient 3. Interesting. And that sign also influences the sign of this thing, which is only negated here. So it is toggled. The sign is being toggled. This sign is being toggled if this sign is toggled. I think I don't have to use it anymore. Yeah, just a jump to the minimum now. So we don't even need this anymore. Oh, now it works. Again, that is now doing the same thing and wants to jump to this minimum. Although now it is done on a for a different reason. Yeah, that's interesting. It stops now. That is different from before. False fails. Up, 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 up. $175. Both have their extreme in the middle now. Yeah, totally. So if only one of them has an extreme in that region, I have to jump to that. What you're doing here, changing that, setting. If and I don't know, it looks a bit ugly. I can do debug. I think debug makes its own scope though. Yeah. Can't use that debug for this one. I could use it for this though. But yeah, well, big thing, I don't know. Okay, so if both of them have the wanted extreme in the right region, then what to do? Then I have to pick the one whose points that I use to fit a cubic through have their center closest to the local extreme, which I guess I could just determine here as well then, calculate it, as in calculate the distance. That distance is equal to going to do the test here, right? I mean, if both of them are true, that means I did get here, and this was true. Now suppose then I get here, and this is also true, then I can do the test right here. and make that decision. Except, well, I still have this a cubic then. I don't have that one anymore. So I need one extra variable then to store that the distance. No, it's nonsense actually. Sorry. It's also not the distance to the center. Close to. Okay, so we have this point. Now imagine that this cubic also has a minimum within here. Then the one that I want to pick is I think the shortest average distance. Maybe it doesn't really matter as long as the limits work. The limit cases. The shortest average distance from this point to the points that made up the cubic, so in this case 0 and 2. So that would be the average between the distance from here to 0 and the distance to 2. That means that since it is in the middle, that is just the distance between 0 and 2. I will divide it by 2. It's a constant actually, if it is in the middle. While if it is outside it, for example, if this was a cubic that fitted the 2 and 1, then the average distance is the distance from this point to the inflection point. Which therefore means, Yeah, well, that would be the average distance, yeah. What does that mean? So if 1 is very close to 2, and the average distance is just the distance of one of them. And if that is shorter than the average distance to 0 and 2, which means that, well, the distance to 2 was equal. So the only way that the average distance is then shorter is when the distance to 0 is shorter than the distance to 2. So we'll a little bit on this side of the middle. I would prefer the 1 and 2 that are super close to each other. And if it's on the other side, it would prefer 0 and 2. You know what? I think that makes sense. Sense enough to just implement it like that. Instead of doing multiplications and stuff, could do, you know, average reciprocal and stuff like that. But I think this will do. So I want the shortest average distance. Average means I'm gonna divide by 2. Let's just not do that. So I want to have the shortest, the smallest sum of the distance to the both points for both cubics, which means yeah, okay. It's just going to involve an absolute value. I don't have a note anymore. I should do this calculation here while I still have all the information. Wait a minute. No, maybe a bit silly to test. Let's just calculate it anyway. I have to do this here as well. Ugly. Yeah, let's test it first. Perfect. So before I had a point over here, so that was 0.0. You know, this thing goes up and then it's a sinus, so it goes down again, and somewhere here in the neighborhood of the maximum we had 0. And then between 0 and 2 lies 3. And then the minimum is between 0 and 3. So now we jump here. And then again, the minimum is going to be 4 and 0. So what I did is it jumped from 3 to, well, 4 and to 5, 6, 7, 8, 9, 10. Slowly creeping closer to this minimum, because continuously I continued with sample 0. So now what I changed is that instead of continuing with sample 0, it's going to use the two samples that are closest. Not sure if you can already see that. Yeah, so now it dropped. God, this is weird. Arrows point the wrong way. Why? Okay, well, not why. That is just wrong, so I have to fix that. I think we should still use 0 actually. No, 0 must point that way and 4 must point that way. Because that is where the minimum lays. But the cubic that I'm using is now the cubic through 3 and 4. Because 3 and 4 are way closer to the minimum than 0, which is all the way up there. Which then gives us a much better approximation, as you can see. And this blue thing here is the real curve, so it's already on top of it. It's just bang on top of the minimum. While this one is the fit through 4 and 0. Hello Lance, no it's not. I'm still doing algorithm, gradient descent algorithm. So otherwise it would have jumped to this point, but now it jumps to the correct point, like way more precise. Victory, but my red arrows are pointing the wrong way. What happens if I press space again? We jump here and then it should, of course, take the cubic through 4 and 5. And we crash because apparently now none lays in that region. That must be between left and right. But yeah, those have the wrong values, so the whole assert is not really a bug. Well, rather, it's good that it assert. It's pointing out the bug that my left off and right off markers are not correct. I'm pretty sure that this was correct. So if I have if right has an extreme, what does that mean? That means that the cubic through the new point and the point on the right has an extreme in the right region. And if left does not have an extreme, then the right off becomes the new node. And the reason is that I might actually be wrong. This used to be correct, but I think it's not correct anymore. Okay, let me think about this. So add a comment here. Yeah. The question is what to set right off and left off to. Hmm. Oh, that worked. I have a new assert. We were talking about floating point round-off errors here, because I just found a local extreme and I didn't abort. But it's still interesting to see then stuff fail, because you never know when that really will happen. I would say theoretically the code should be so robust that if my comment says that it can't happen, then it should not never happen, period. How do I debug this? This is a call to initialize cubic. So this is already extremely inside. I think it actually, no, we don't. I don't know what the minimum is, but it is. Okay, that's the value. So it doesn't even change at all anymore. And as if you can even do it again. Oh no, you cannot. Maybe with just 2 points that are equal or something. Obviously that's 2. Streams 1. That is the value. And it says extremes 1 cannot lay in between W and next W. Yup, it does. That's 1 continue. 2 continues. 3 continues. 4 continues. 5 continues. It already went further than before, I think. Okay, the sixth continue, it seems. Let's count that again. Yup. These points are super close together. Very close together. And the derivatives are almost zero. Not that zero. So this one is also, I mean, if it's not zero, it's not in the minimum, it's not in the minimum, it should be larger. So this should be larger than that one. 1617 or so. Okay, and then this one is larger. Oh. It is larger, but I had expected a little bit more, but okay. Well, that does give us a cubic, of course, one way or another. So I'm gonna do next. Print cubic. Those are some hefty numbers. It doesn't seem to make much sense at all. Yeah, that's just ridiculous. These numbers are bullshit. This is nothing to do with the cubic. So we have some really freaky cubic because of round-off errors and stuff. Okay, this is just for the color. Yeah, I don't know. It seems like this is just floating point around of stuff. So, well, I'm sure it doesn't work anymore. I think I need a break. Should eat something as well. What is this guy doing? They should probably play this pawn. Like anyway. Preparing this. I take. Who cares? Push. Take here. Create a weak pawn. He's still doing moves all the time that belong to a different opening. And resign. Yeah. This is more like how I know those 1800 players. Like impossible to lose from. Let's see. You want to? I take here, pins my knight. To take that or doubles my pawn. I don't like that. I think I can get it anyway. Let's do this. It's gonna pin it anyway now. Do. Could do this and then go here on my king. And then the bishop comes there. But I threaten to do this one. I think it's gonna work. Maybe just develop my bishop though. Yeah. So defend this one. And then defend the knight. And the bishop would also go back here actually. Oh, that's a stupid move. Oh, I can't take it because he takes here. Okay. Yeah. Do that. Did it anyway. Now it's attacked twice and I can't move. Totally going to take the pawn. Got a point. It's equal material, but I have the feeling I'm +8 or something. Seriously. Exchange. Yeah, my knight is not doing anything there, is it? Just take it. that one pawn enough? I think so. There's also two isolated pawns. Okay, I take this pawn, I take that pawn, and then I take this pawn. That looks pretty good for me. Here, check, I go there. Maybe he takes that pawn. But after he takes, I go there, so definitely win this pawn. And then I just walk. Yeah, come on. This just really has to win. Hmm. She fun spendy. Yeah, just casually. I play chess when I get so tired that I can't code anymore, or just before I get up from the computer. Yeah, I'm gonna eat dinner, watch a movie. What else? Then come back, I guess.